Hello students, this is Miss Dalton, and this video is an introduction to logarithms. A logarithmic function is the inverse of an exponential function. So given an exponential function that is a to the y equals x, a logarithm is defined as log base a of x equals y. Now, something I want you to notice about both of these is that the a, which is called the base, this is considered the base in both of them. So the base of the exponential and the base of the logarithm, they're both called bases. So you just want to make sure that you understand where that goes. Now, sometimes people refer to this as kind of a circle. So if I'm going to convert an exponent into a log, we can start with our base always. And so log base a of x, and then it circles around, equals y. And so you can kind of think about that when you're converting back and forth. Now, so here are some examples of exponentials and logs that have been converted. So 2 to the 4th equals 16. When you convert it to a log, you're going to have log base 2 of 16 equals 4. And the other thing I want you to recognize is that whatever the log is equal to, this is considered the exponent. So again, because a log is the inverse of an exponent, that's what the log is going to equal. The log is going to equal the exponent. So here we have log base 2 of 8 equals 3. When we convert that to an exponent, that again, we're starting with our base 2 and we're raising it up to the exponent of 3, and then it equals 8. And so that's how we get this right here. 5 to the 4th equals 625. It converts to a log as log base 5 of 625 is equal to 4. All right, and here is just some basic log properties. If you have log base a of 1, and so you can have any base, it does not matter what it is, but if it's log base anything of 1, it's always going to equal 0. And that's because anything to the 0 power is equal to 1. Log base a of a, so if these match, then it's just 1, because a to the first power is equal to a. And then if these match right here, and there's an exponent there, the log base a of a to the x is equal to x, because if we convert this to an exponent, we would have a to the x equal to a to the x. All right, so in this first example, we're just going to be converting these from log form into exponential form. And so if you'll always remember to start with your base and write that down as your base, come over here and pick up your exponent, and then it's equal to this number right here. And it should be a true statement. 7 squared is 49, and so you know that you've got it right. Okay, over here, part B, it says log base 3 of 1 over 27 is equal to negative 3. Start with your base, 3. Come and pick up your exponent, and then it's going to be equal to 1 over 27. And this is a true statement as well. Remember, when you have a negative exponent, you're going to end up with a fraction. And so anything to the negative power is going to give you a fraction. For example 2, we're taking an exponent and we're going to convert it back into a log. So again, I want you to start with the base. This is your base. So when you first write down the log, make that your subscript. So log base 8, and then you jump over here and write this down of 64, and it's always going to be equal to the exponent. And so this is how you convert it. Okay, part B, start with your base. So log base 1/2, make sure that I can tell that that's a subscript too. 1/2, and then you come over here and you pick this up and write it right beside it, and then it's equal to the exponent. Your log will always be equal to the exponent. So if you're having a hard time figuring out where everything goes, you know what your base is, and you know that it has to equal the exponent, and so then the other part has to go right here. All right, so now we're going to solve or evaluate some logs. So we have log base 1/2 of 8, and then we want to know what that equals. So the first thing you're going to do is you're going to set it equal to x, because we're going to have to try to find out what that equals. And then I want you to convert it into an exponent. It's going to be a lot easier to solve it when it's in exponential form. Start with your base 1/2, raise it up to the exponent, and then set it equal to 8. Well, anytime you have a fraction that goes to a whole number, you know that your exponent is going to be a negative, okay? So we know that x is going to equal a negative something. So you just have to think, okay, well, if I turn this around, that's going to be 2, and 2 to what power is equal to 8? That's what you're asking yourself. Well, 2 to the third power equals 8, so this must be -3. The negative flips it and makes it a 2, and then 2 to the third power is equal to 8, and so therefore this is your answer. Let's check this next one. First thing I want you to do is set it equal to x. This is going to help you convert it to an exponent. Then start with your base, raise it up to this exponent, and it's equal to 512. So we have to see if we can find what power of 8 equals 512, if that even works. So if you try a few things on your calculator, you know it's not 8 squared because that equals 64, but 8 to the third equals 512. So that x is equal to 3. All right, let's look at this next one. Log base 5 of 625. Set it equal to x. Convert it. 5 to the x power is equal to 625. And then what power of 5 equals 625? It's the power of 4. So x is equal to 4. Here, set this one equal to x. Do 16 to the x power equals 1/4. Okay, and notice that this is turning into a fraction, right? So we know that x is going to be equal to a negative. And so let's go ahead and flip that around and make it 1/16 to the x. And so then the other thing I want you to realize is that the numbers are getting smaller, right? We're going from 16 down to 4. So that means that we're going to probably take the square root or cube root or something. And if you remember that the square root of 1/16 is equal to 1/4. Well, how do you write a square root as an exponent? Well, you'd have to write it as the 1/2 power, right? The square root of something is equal to that something to the 1/2 power. So that means that the x is a -1/2, so that we can get a fraction, but we can also go backwards to the 4. All right, that's it for this video. This is a challenging topic, so please make sure you have your questions ready, and let me know how I can help.